Vivek, can I ask you about Bolt? And are you sort of looking at regional differences in your models? Or are you trying to deploy a single model for L4? Is it hybrid? Is it end to end? What is your strategy for that?
No, hybrid, I agree with Sebastian. It's going to be end-to-end in the future. Why we need hybrid today is we don't have a way to prove safety of end-to-end. As simple as that. As we are, last year, we were not in this position. In 1 year, we will figure out how to prove safety in AI as well. That's a solved problem. But I think fundamentally, we are undermining the step to go from L3 to L4. Okay, now I talk L4, I always talk about commercial L4s. I don't talk about private cars. Someone used the horse strategy or analogy in the previous panel. I would like to use it. So what we are doing, L2, is you are sitting in a horse and you are biologically connected to the horse and you are riding the horse. Then L3, just to compare, L2, L3, L4. L3 is when you invented wheels, 3,500 BC, and put a horse carriage, where you are sitting behind, you could fall asleep. This horse, it will know its way back to home, it will not idiotically run into a wall, so it was basically L3. Animal intelligence, not artificial intelligence. We removed it. Someone also said we were regressed when we invented automotive. But the thing is, inventing automotive, so going from horse carriage to automotive or machine-driven engine-based cars, we are somehow thinking that's the natural next step. So L4 is the natural next step. No, we are going from horse-driven carriages, which we became drivers from riders, and we are going to become riders of an airplane. I think that's why I liked Arthur when he presented. We have to. This is not a CES that we are talking about. This is something else. Please compare apples to apples. So I do not believe this. Solving L3 will solve L4. And there is no need to it as well, because L4 is a commercial business. If there is a car that can go from A to B whenever, wherever, I don't want to own the car. I would like to subscribe to the car. And it can do something else. I don't want to keep maintaining it and stuff. So I would rather also like to not identify regulations to say, can you explain AI for L4? Can you explain? No. Think about the usage of it. Are you driving or riding? And then separate those two, would be my recommendation.
Eric, can I ask, inside you mentioned regulation and regionalization being important factors, but how do we sort of measure progress when we have these sort of different flavors of things depending on what the local regulation, what the local capabilities are? How do you measure inside of your business how your progress in this L3 to L4 transition?
So typically there are KPIs, and those KPIs are being placed on us by our customers, whether it's public transportation operators or fleet owners. So there are several milestones that we need to cross. So I agree with that end-to-end approach. So for example, at the beginning, we are required to pass NCAP testing for autonomous buses, for example, meaning that they want to see that whatever was applied, like, I don't know, 20 years ago, on passenger vehicles now could be applied on buses, meaning that that bus can drive now 90 different scenarios, braking between 30 to 60 kilometers per hour, and can brake automatically with all kinds of stuff that are jumping before the bus. So that's just gate number one. Then, in order to get to the next level, another KPI is how safe it is, meaning I think that I've heard the word safety until now from the morning probably 50 times. But what is safety? So we define safety in level 4, for example, by cyber vulnerability. So, when we complied with the UNR 155, which is mandatory in Europe, but doesn't exist in most parts of the world, then it means that we pass the next KPI. So now we can really board people onto the mass public transportation autonomous vehicles because now it's safe. There is now a Senate investigation, right, about 90% of the robotaxis in the US where you could remotely drive them, which is obviously, a national threat. So that's the next KPI. Then the next KPI is obviously how good does it drive? because I completely agree. Level 4, it's a commercial service, meaning because that's where the benefit is. If we provide 100 buses to a public transportation operator, they only earn their benefit when we pull out the driver. So you know, when we get to a certain milestone, let's say 100,000 autonomous kilometers with no intervention, nothing had happened in those 100,000 autonomous kilometers. That's a milestone. That's a KPI. So that's how we measure progress.
I want to touch more on safety in a minute, but first I'd like to ask Sebastian, there's been a renewed optimism, right, for autonomous vehicles in the last few years. It was considered to be behind schedule, and now in the last couple of years, things have really sort of picked up pace, and there's a new optimism in the industry. What milestones have you seen that you think are causing that optimism? And is it AI capabilities? Is it just renewed research and investment in AI, or is it something else?
Couple of reasons. In general, everything goes in waves, right? ADAS industry haven't stopped. Just like because there were no articles, the development departments are still running and R&D is progressing fast, right? So in conjunction with progresses in AI, big models and neural networks, you basically saw that the capabilities are going to achieve what you are aiming for, and this is like end-to-end driving with a big AI model in the background. Combining that and making up like a strategy was the same thing like all the suppliers worldwide did. And I still need to mention it, Tesla jumping in and pulling out of the hat, like we are going to turn every car into a robotaxi, was also fire starter for most of the businesses to explore and basically see that this kind of vision is the next to follow. So definitely. On the other end, you also see like from like the progressing in ADAS system development that L2++ introduction in China was one of the other reasons why the progress was also accelerating so fast. So you got a mass scale introduction of end-to-end models in vehicles. So right now in China, all cars are sold with an end-to-end system already. So the majority of the models coming into place right now. So there are more than 1 million cars running around with an active Tesla-like, Tesla FSD-like functionality. And you train with this kind of information that you receive from the cars, the AI models, and you can see that you can achieve the next step. And from a regulator point of view, when you look at China, or maybe ask a question in the audience, who believes in level 3? Maybe raise your hand if you believe in level 3. No, one hand over here, one hand, yeah? So just like, just a fact from China. So China is going to change the regulation for level 3 at the end of the year. So cars will be allowed to have a level 3 operating system in China by the start of next year. My company has more than several SOPs planned with the start of 2027 with an L3 system that allows level 3 driving on highway. So it's not a question of believing in it, it's already planned. It's there.
And there's such a gravity to that data as well. Like the more miles that we have driven autonomously, the easier it becomes to add more miles to it. And I think that data keeps feeding through and reinforcing the models, reinforcing the research behind the models.
Yeah, sure. So it's at the end the long tail issue of autonomous driving. You need to see like all the edge cases, and the edge cases can just be seen when you collect a lot of data. Yeah. So this is one of the key points. And some companies do it by city, by amassing amount of data, storing, building digital twins. There are several approaches. Or you train with all the cars in the field, with millions of cars, to train an AI model that is deployable instantly.
Bertha, you had something to add, sir?
Yes, to your question, do we believe in L3? I think does OEM believe in L3? Why do we keep calling L2 plus? It's because we don't want to take the liability as an OEM. If one thing goes wrong, I don't want to end up stalling my 100,000 vehicle. As simple as that. There is no, like AEB, right? When that came in, everyone was like, oh, what do we do with this? How do we regulate this? And we found out something, a checklist to do it. And for L3 as well, at some point in time, the regulation and everything will fall in place. There is ALKS already today. Mercedes cracked it, but there is not enough uptime for it, as simple as that. So deploying in China is one thing about regulation and stuff, but what is the uptime in Europe? And do we have, does end-to-end AI solve the uptime for L3? Or do I have to chase for traffic and queue in order to get buck for the money if I'm paying 5,000 euros per year? That's the question. I think everyone would love to, I would love to have L3 as well. I would rather, as a private car, I would never want to have L4. I would like to, like the horse, you know, you just guide it when there is traffic. When there is no traffic, it just goes by itself. I would rather like to do that with L3. But the question is, when are we brave enough, bold enough to bring that to Europe?
And I think I'm going to ask on this. I think this is a question that everyone will want to jump in on. What is it going to take to deliver safe, reliable, autonomous systems on public roads at scale?
So first of all, it was said here, it's data. The secret sauce, and I agree with that, is to have sufficient data. And you know, Tesla passed, I think, 1.5 billion miles at the end of last year. So they collected sufficient data in order to run their models, because developing AI-based systems, it's not the coding that it's difficult. That's, you know, in many cases, you know, there are now all kinds of engines that write the code by itself. So that's not the thing. The secret sauce to it is that you'll have sufficient data to train the neural networks on that. So you need to have hundreds of millions of images and cases, and that's only once you get to that level that you've tested it all, you know that would, because it learns like a human, right? We have the perception, we have maybe different ways of doing perception, but at the end of the day, we all end up with a map. That is, you know, kind of a digital reflection of everything surrounding the vehicle, 360 degrees, 300 meters. The difference is in what we call the cortex, basically the motion planning part, which is built with a technology that is basically deep convolutional neural networks. So it's a true form of AI, meaning it teaches itself to drive better and better, just like a human being. That's how we grew up. That's how we were trained to drive and to do many other different activities. So that's the level of AI that we're talking with. And there was, we mentioned before also the computing, meaning we believed from the get-go, which was 2018, by Moore's law, that at some point in time, there would be sufficient computing in vehicles, like edge computing within the vehicle, that could run those AI machines. And that inflection point, that only, because, you know, we were talking about autonomous driving vehicles for like 10 years at least, but it only really happened at scale 2 years ago. Why? Because a few silicon companies, Qualcomm with the Snapdragon, and Nvidia, and ZF High Performance Computing, and Umbrella, and Recogni, and others, got to that point that we could place sufficient computing in a vehicle to run those models that we're all developing. That's really that's the tipping point. That's what made it possible.
Sebastian, would you like to join in?
No, he's right. Yeah.
He's right. Okay, that's good.
Yeah, the key, I think the key is, yes, data, but also what you touched upon, it's the ecosystem. Every piece of the puzzle should grow for us to reach a sharper point. Today, we are all trying to find our position in the value chain. We talked about value chain already as well, because I like to compare it always with the aeronautics and the industry. Now, today, we know what Lufthansa does, what does Aerobus mean. Today, we know, because we know that's a flight manufacturer. This is where I go into an app where I book the ticket and stuff. They have found their positions in the value chain. The problem we have is that we are in the forefront of innovation. We are thinking OEMs should scale. We have end-to-end AI. We have hardware that is coming through. There is fleet operators that are getting into the business saying, yeah, we have to be part of this as well. So everyone is trying to say, what do I own in the value chain? Sooner, we will all find, yeah, this is my core business. Waymo also wanted to only do autonomy, but now they are doing the whole chain because there was no one else doing it. So sooner or later, we will all identify where we belong. And then this is an easier puzzle to solve, because now then the burden is shared. And it's important to see it as an ecosystem from the beginning, not as who wins this race, but it's an ecosystem, a shared ecosystem.
So I think we have time for one quick round on, I think you're not pro on consumer L4? Anyone else have a different take on consumer L4?
We are not doing consumer.
Not doing consumer?
We're
Maybe the
selling
audience
we
would
are
like
selling
to.
enterprise.
Does anyone here believe in consumer L4? Okay, well, we just saved a bunch of people a lot of capital seed money there, I think. So we do have time for a quick question from the audience if anyone wants to ask something in particular. Yeah. Get you a mic, hold on.
I'm Jürgen Biffer. Just a question. You said it's all about data and having all the training data, which finally form the models which we would run in the cars. To get this data, one could think that, let's say, a company like Waymo is so far ahead of the rest of the pack because they have just collected the data in a, let's say, Western country. Now, if we think about Europe, no one so far has collected so many data. Just in theory, almost all cars which we have or which are built today have all these cameras, etc., but they are not collecting the data. So let's take a company like Stellantis or Volkswagen with a lot of cars, with a lot of cameras, and they would start just recording the data and using the data. Would they, in theory, be, after a year, on a similar level like a Waymo was and could use that for their AI models?
I'll start. Yeah, sure. So not necessarily, because and that's really the beauty of technology. You see, Waymo and Tesla and Zoox and other like large companies, you know, big tech, they took the approach that is called in AI the brute force approach. So they developed an end-to-end. I might get a little bit too technical, but I'll try to explain it in a simpler way. So they took the brute force approach in which you build one big neural network and you need an immense amount of data because you need to train that one big neural network that does everything end to end on everything. So that's kind of a very... Instead, we took a different approach because we are still a startup. Now we are maybe a scale-up, but so we took an approach that technologically we built another solution that is distributed neural network architecture, in which instead of one big neural network, there are many, many small neural networks, and each network was trained separately with hundreds of millions of images on object detection and classification of a different type of object. So one is doing traffic lights, and one traffic signs, and one pedestrians, and one lanes, and so on. And then we build in real time, one on top of the others, that three-dimensional map that represents the perception. This enables you to train the networks with a friction of the data that is needed with the brutal approach. And it's also much more cost effective because then you can run technically different neural networks on different cores of the computing, so you don't need those crazy computers, and you can do enough with Qualcomm or with a TI. Okay, you don't need the latest Thor of Nvidia and stuff like that in order to make it cost effective. So you can see that it's also the technology that you choose and your solution, and not just okay, let's collect now data from 10,000 vehicles driving in Europe with cameras and loading it to the cloud. You need to think before of how you're going to do that.
Viveka, you wanted to add
Yes,
something?
I would like to give a fleet operator perspective into it, just for L4. For L3, they will solve it by collecting a lot of data and doing end-to-end. But L4, also as a fleet operator, many have asked, you're as a fleet operator everywhere with your fleet, would you like to share your data? And here is where the European sovereignty, data, everything. First of all, as a company, even if you collect data, you're not allowed to just share it or sell it because of GDPR, and we all know that. There is DCAS that is in place. There are so many regulations in place. This is why we as Bolt as well, I don't know if you have seen, we had an announcement with Nvidia. We clearly see there is a need to have a data management system that goes across Europe, at least Europe first, because then we share data, don't sell data. We need to somehow democratize data. Only then we can move forward faster. And then this means not data just from the vehicle. Yes, the sensors. I would leave the sensors and the camera that detects the VIN numbers and all that. I would leave that to the OEMs to solve it and the ADS providers to solve it. It's the data of our customers, their banking accounts are in then their PUDO points, what do they do every day, their routine, everything is in our fleet operation system as well. We have to protect that. So there are multiple layers of data and how we manage it and how can we utilize the strength and the muscles each company has to share and also go it together. I would say it like that. And you would see soon from Bolt's side as well. This is key, and this is the foundation that we will build it on to be able to scale.
Maybe answering the question directly. So can a company like Stellantis do it? For sure, they can. There are companies outside that out there that are doing that, right? So if you look at Tesla, it's exactly what they do. They collect their data on their own. There are companies in China like Li Auto, Chopin, NIO, all have their own ADAS development department, and all of them develop their own ADAS stack. Second factor is it takes time. So it's like developing operation system. So it takes up to 5 to 7 years to really develop a good end-to-end system that is trained on data. It takes time. So you cannot do it like instantly. Then the question is like a business perspective. So why do it now when there is already solutions in the market that you can purchase and put in your car? So it's a business case decision to do that or to self-develop it. The other hand is scalability. Can you reach the penetration in terms of data collection? So when you produce 100,000 cars a year globally, is it going to compete with a system that relies on millions of cars in data collection? So the quality might be different as well. And the other part is the sensor setup. So about what kind of data are we talking when we talk about data collection? So if you do collect data with a 3-camera system, it's not going to do anything for your end-to-end system that relies on 11 cameras. Then you need to recollect everything because you need cars in the field that matches to a certain degree the sensor setup that is collecting the data for your end-to-end system.
I think that's it for time, but thank you so much. It's been a great discussion. Really, thanks. A real pleasure for having you all here with us today. And thanks very much from the audience. Thank you.